All right, welcome to The Explainer. Today, we are diving into one of the coolest and most powerful tools in machine learning, the random forest. Now, I know the name sounds a little intimidating, but the idea behind it, it's actually something you already know and probably use all the time.
I mean, just think about it for a second. When you're facing a really big decision, something important, do you go to just one person, a single expert, and take their word as gospel? Or do you ask a bunch of different people, friends, family, colleagues, to get a whole range of opinions? Yeah, most of us go with the group, right? Because we're tapping into the wisdom of the crowd.
And that right there is the core idea of a random forest. It's a machine learning algorithm that doesn't just build one predictive model, or tree, it builds an entire forest of them. Each tree gets a vote, and then the algorithm combines all those votes to come up with a final answer that is way, way more accurate than what any single tree could manage on its own.
So, here's what we're going to cover in this explainer. We'll start with what a random forest really is. Then we'll get into how it actually works. We'll explore why it's so powerful, see it in action with some real-world examples, and finally, we'll wrap up with the pros and cons.
So, first up, what exactly is a random forest? Well, it's a perfect example of something called ensemble learning. An ensemble is just a fancy word for group. In machine learning, it just means we're combining a bunch of different models to get a much better result than any single one of them could give us alone.
This quote just nails it, doesn't it? Think about it. A single decision tree might have its own weird biases, or maybe it makes a mistake because of the specific data it was trained on. But if you create hundreds of slightly different trees, all their little individual mistakes and biases, they tend to cancel each other out. And what you're left with is a final answer that's way more stable and accurate.
Okay, so that's the big idea. But how does the algorithm actually build this forest and then, listen to all the different opinions? It's a really clever four-step process. First, it creates a whole bunch of decision trees, and, this is key, each one is built using a random sample of your data. Second, as each tree is being built, it's only allowed to look at a random handful of your data's features. This double whammy of randomness is so important because it guarantees that all the trees are different. They're all looking at your problem from a slightly different angle. Third, each of these unique trees makes its own prediction. And finally, the algorithm gathers up all those predictions and combines them.
So how does it combine them? Well, it depends on what you're asking. If it's a classification problem, like is this picture a cat or a dog, the algorithm just takes a majority vote. Whichever category gets the most votes from the trees wins. Simple as that. But if it's a regression problem, like how much will this house sell for, it takes the average of all the numerical predictions from all the different trees. It's elegant, and it is seriously effective.
Now, this process might sound pretty straightforward, but the results are just incredibly effective. So let's break down exactly why random forest is such a go-to algorithm for pretty much any data scientist.
I mean, look at this list. The benefits are huge. It can handle missing data without you having to do a ton of cleanup first. It can actually tell you which of your data points were the most important for making the final decision, which is awesome. It handles huge, complex data sets like a champ. And this is a big one. It dramatically reduces the risk of overfitting. That's when a model gets too smart for its own good and just memorizes the training data instead of learning the actual patterns. Oh, and bonus, you usually don't need to normalize your data beforehand.
Okay, theory is cool, but where is this stuff actually used? Let's look at how random forests solve real problems every day, from predicting fates on historical shipwrecks to pricing modern real estate.
Our first example is a total classic in the machine learning world, trying to predict who survived the sinking of the Titanic. This is a classification task, right? Because the outcome is one of two distinct categories. You either survived or you didn't.
So a random forest model would chew on a dataset full of passenger info. For each person, it looks at features like their ticket class, their sex, their age, and every single tree in the forest gets to vote on whether that person made it. So for a third-class male passenger, the overwhelming majority vote is probably going to be did not survive. But for a first-class female passenger, the forest consensus prediction is survived. It just shows how the model picks up on these subtle patterns in the data to make its call.
All right, let's switch gears from classification to regression. Here, the goal isn't to pick a category, but to predict a specific number, in this case, the price of a house.
For this kind of task, the model takes in all these different features about a house. The median income in the neighborhood, how old the house is, things like that. Every one of the hundreds of trees in the forest will spit out its own price prediction. And the final number you see? It's literally just the average of all those individual guesses. And as you can see, man, it can get incredibly close to the real price.
Now, as powerful as this algorithm is, it's not a magic wand. Nothing is, right? It's always super important to understand the trade-offs, so let's get a balanced view of where random forest shines and where it has its limits.
So on the plus side, you get crazy good accuracy. It's great with messy data, and it's really robust against overfitting. The main downsides? Well, because you're building maybe hundreds or even thousands of trees, it can be slow. It can take a lot of computational horsepower. And while a single decision tree is pretty easy to look at and understand, a whole forest of them is kind of like a black box. It's much, much harder to pinpoint exactly why it made the decision it did. So if there's just one thing you take away from all of this, let it be this right here. A diverse collection of simple models can actually be a whole lot smarter and a whole lot more reliable than one single super complex model. That, at its heart, is the power of the random forest.
And that kind of leaves us with one last question to chew on. This whole principle of combining lots of simple, diverse viewpoints, it doesn't just apply to computers. So where else in our world, in technology, maybe in society itself, is this incredible wisdom of the crowd hiding in plain sight? Thanks for watching The Explainer.